375, standard deviation 125. Q3B is asking you for the worst 1% days. 3 with big nose.
What is that? Is that a B?
That makes me wish another paper. We have
Oh, it's
375 for every single day
I thought
twice.
it was
This is the S&P 500 daily return.
Isn't the standard deviation 1.76?
Okay, that's a question. Okay, question 3, part B. For the worst 1% of days, how much can S&P 500 lose? Okay, the 1.76 basis point
Was for the 50.
is for the day that's daily mean average estimate. If you want to use that, I need to ask you this: for the worst 1% mean estimate, okay, what is the daily return? I wasn't asking that.
Okay.
I was asking just for a typical day. Say over the next 100 days, the worst day, how much do you expect to lose?
The 1.76 standard deviation, is that the standard deviation of the daily mean? Or
Is
the
the
mean over?
standard deviation the daily mean estimate? Each day has a standard deviation of 125. Okay? So that estimate, once you have many years of data, you try to estimate each day on average how much you make. Because the daily standard deviation is so large, it's very hard to make that estimate. Okay? Remember, standard deviation only goes down at the rate of square root of time. With 5,000 days, standard deviation is still 1.76 for the daily estimate. Let's say you want to make it half as big. Instead of 1.76, you want to make it 0.9 standard deviation. Then you need 4 times more data. This is already 20 years. 4 times more data means 80 years. We don't have 80 years. Okay? We don't have that many years of data for stock exchange. I guess we do, but in between World War II, stock market closed for many years. We don't even have the continuous data from going back that long. Okay, that far back.
what I'm looking.
All right. So this is asking you. This has a name. Okay. When you do risk management in a company, say you're JP Morgan. Okay. You want to know what's your 1%? What's your 1% VAR? What's your 1% value at risk? This is asking that. What is your 1%? What is for the worst 1% days? How much do you expect to lose?
Q3, 1%.
Okay? So this is so-called a VAR number, value at risk number. Okay? So here, this is a normal distribution, 125 standard deviation. So I want to figure out for my worst 1% days, this is 1%. What is this number? I call this the VAR number. Okay? VAR number typically write as B, uppercase B, lowercase a, uppercase R. I don't know why. Otherwise, you get confused with variance. So you can write B, small a, big R. Okay?
Okay.
So what's your VAR number?
So,
What's your 1% VAR number?
100.
Right? Find the Z-score
Yeah.
for 1%.
Mm-hmm.
It's negative 2.9. Then find out the return corresponds to that Z-score. Okay? This is the same as, I guess, if you 1% on this side, 1% on that side, that's like 2% on both sides. This is like the same thing as finding your lower bound for 98% confidence interval.
Right.
Okay? All right, so what's the Z-score for
This is crazy.
1% CDS? So look on the table. Look on the table. Look at. So somewhere in the middle, look for 1%. And find out the Z-score.
That's 2%. 2.3.
4%?
Yeah, 2.33.
Negative.
You're using table,
Negative and positive.
you're using the table in backward manner. You look for 1% in the middle, and then you see what this score give you that probability, okay? Everybody, you all know how to find out this? 2.33. So how much you lose for the worst 1% days?
That is the whole bond, right?
Yes.
So the bar number minus the mean divided by standard deviation should give you minus 2.33. Okay? So the solve for VAR give you minus 2. Someone help me the other class. Minus 287 basis points. Based on this distribution, for the worst 1% of days, you lose about almost 3%, not 3% yet. Actually, that number is small because we're based on we use normal distribution. Right? JP Morgan lost $6 billion, so-called London whale trade, but they got fined $4 billion on top of it by the regulators. They really lost $10 billion.
All right, so how do you get that 2.33, 1%? It has to be in the minus, right? Oh. Okay. I was looking at the wrong sheet.
But she gives me a treat. We got 99%.
Uh-huh.
99. Yeah,
Well, you're looking for 0.09.
9. So this is the CDF. C-score. The 1%.
Uh-huh.
So it's negative. Because you're losing.
I gotta read some more.
Yeah, but it's just like
It's the opposite. Sorry.
Hold on. For those of you interested in risk management, okay, you work for JP Morgan. You can trade with the chief risk officer sets the position size of different trading desks. Okay, they do that calculation. They say, all right, based on your strategy, you can lose 2.87% in the 1% worst days. They say, all right, if I want to set a position limit. Say, I don't want, the most you can lose, if you're really big, very, very successful trader, run a big book, they can allow you to lose $100 million in a single day. Okay? So, so if 2.87% is $100 million, so 100 million divided by 2.87 is how much position they allow you to take on.
Wow.
Okay? But if you just started, most likely your daily value at risk is like a 1 million. Okay, you can lose a million. When you get bigger, if you're making money for the firm, they increase your position size. Okay, to allow you to make more money for the firm. Okay, but 100 million in a day usually is usually the top of a particular trading desk. Okay.
Is it negative 2.87? But I got negative 287.
287 point.
287 basis points. 2.87%.
Oh, all right, so right. Okay, all right. So can you just interpret that in financial, like,
That's the financial linguistics says this is the 1% bar number, value at the risk number. Okay? 2.87%, that's in percentage term. You can also make it in dollar term. Say if you run $100 million book, okay, $100 million book, that means you can lose 2.87 million for the worst 1%.
for the worst, there we go, for the worst 1%.
Second part, how much can you make?
How much you can make the same thing.
Positive.
2.33. These are all the same. Okay? You make it 95.
It's sort of predicated on the fact that it's normal.
usually it's way bigger. Once you put like a tea infusion or some weird fat heavy.
Is the distribution derived from like historical data?
Here, we're seeing normal, but dark is not normal, more like even the kiwi distribution. Big job for this man. Nicely.